Hey, what's going on, guys? Let's do this problem right here. We have this function right here. Let's see how we can integrate this one. So to do this one, what I have to do, first of all, I take this infinity and put it as a limit. So that's the first thing we do. So this is going to be limit. So let's say t approaches infinity, and that's going to be here. Now instead of this infinity, I put the t. So it's going to be 0 to t s e power minus 5 s, right, s ds, and this is what we get. Then what we do, we try to integrate this one using, there are many ways we can do this, but let's choose the best way. So in this case it seems like integration by parts works best, so let's choose that one. So let's see. Okay, we have this one right here, integral sc power minus 5 s ds. Now I had to pick up a u and v dv value. So if I pick up a u value, I have to pick, usually we pick the one that is easy to find the derivative, right? So u, if I take the s, that's easy. So the derivative of this one is going to be just ds, right? This is going to be ds, and rest of them is going to be my dv. So dv is going to be e power minus 5 s ds. E power minus 5 s ds, e power s, okay, e power minus s ds. And if I find the antiderivative of this one, if I integrate this one, let's see what we get. So if v is going to be equal to this negative 5 come to the bottom, and this is going to remain the same on top. So that's going to be minus 1 over 5 e power minus 5 s. Then we use this formula, integral u dv, that's going to be equal to uv minus integral of v du. So in this case u is s, so s times 1 minus 1 over 5 e power minus s. I can write this in front, so it's going to be minus 1 over 5 e power minus 5 s minus integral of v, that is this one right here. So minus minus is going to become plus. I can write the 1 over 5 in front, since this is a constant. I can write it in front of the integral. So in the integral we are going to have e power minus 5 and du, that's going to be ds. So this is going to be e power minus 5 s ds. Now this one is easy to integrate. So this is going to be 1 over 5 s e power minus 5 s plus 1 over 5, and if I integrate this one, we already did it right here, it's going to be same as this, right? That's going to be again minus 1 over 5. So again, so multiply by minus 1 over 5 e power minus 5 s. So this is going to be like this, e power minus 5 s. Yeah. So this is, we can multiply this one and simplify. That's going to be minus 1 over 25. So in front we are going to have this one. So this is going to be minus 1 over 5 s e power minus 5 s minus 1 over 25 e power minus 5 s. So this is our integrated form right now. So let's bring the limit back by continuing this one right here. So if I bring the limit back, limit, so we limit t approaches infinity, that's the function, right? Limit t approaches infinity, and let's write this all these thing in the bracket. So this is going to be minus 1 over 5 s e power minus 5 s, wait, this is power s, right? This is power s. It's power s. Then we have, this is also power s. e power minus 5s. Then we have minus 1 over 25 e power minus 5s again. That is from 0 to t. Here, this one, 0 to t, and this is our integrated form. Now what we try to do is we try to apply this t, but before that let's write this in terms of t. Limit t approaches infinity, and we took, so the t is that t is what we are going to apply for s. So let's switch s with t. Minus 1 over 5 t e minus 5 t minus 1 over 25 e power minus 5 t 0 to t, and that's the function. So if I apply this one right here, we are going to get this one, that is limit t approaches infinity, and if I apply t, this is going to be same thing as this, minus 1 over 5 t e minus 5 t minus 1 over 25 e power minus 5 t. Then what we have to do, we have to apply this 0, that's going to be minus, and if I apply t 0 for this t, what's going to happen? 0, and this is e power 0 is going to be 0, this is going to be 0, this is going to be 0, and this is e power 0 is 1, so we get e power minus infinity, e power 0 is 1, so 1 multiplied by 1 over 25, that's going to be just 1 over 25. 1 over 25 times 1, right? So this is what we get. So let's plug this infinity and see what happens. So if I plug infinity for this one, e power minus infinity, that's going to be 0. So this is not a problem. But here, if I apply 0 right here, 0, and this is, no, this is, if I apply infinity, because t approaching infinity, if I apply infinity, this is going to be infinity, and this is going to be e power minus infinity, right? That's going to be 0. This is not a problem because e power minus infinity is just 0, but this is a problem right here, because if we multiply this, this is 0 means this is a small number. If we multiply infinity by a small number, we can't assume that it is 0. So we have to make sure whether it is 0 or infinity, but because we are multiplying a small number by big number, anything is possible. We say this is indeterminate, right? So in this case, what we do, we use the L'Hopital rule to find out whether it is 0. So let's use the L'Hopital rule. Limit t approaches infinity. So I am taking only this part right here, t e minus 5t, and I have to bring the format infinity over infinity, so I can rearrange this one, so t over e power 5t. So this is now in infinity over infinity format. I can apply the L'Hopital rule, right? So this is going to be, if I apply the L'Hopital rule, I have to find the derivative of this one. So in the top, if I take the derivatives, it's going to be just 1, and in the bottom, if I take the derivative, so inside derivative is going to be 5. Outside derivative is going to be just e power 5t, and inside derivative is going to be 5. So 5 is going to be in front, e power 5t. Now we can assume that 1 over, if I apply this infinity for this t, 1 over infinity, right? That's going to be equal to 0. Now we know this is equal to 0. Therefore, this number multiplied by 0, this is going to be 0. Therefore, the answer is going to be 0 minus 0 minus 0. Here we are going to get plus 25, plus 1 over 25, and that's going to be the answer, 1 over 25, right? Plus 1 over 25, and this is a finite number. Since this is a finite number, we call this one convergent integral, because this value is equal to this one. So in the improper integral, if we have something like a finite number, we call that convergent integral. So this is a convergent integral, and that's how it's done. I hope you guys like this video. See you next time.